Good morning and good evening. Welcome to day 3 of ONIF, Open Networking and Edge Executive Forum. As you know, we experimented with 3 time zones over 3 days, 3 hours each. And thank you all for joining. It has been a tremendous success with over 1,000 registered and some of the best lineup of speakers that we have. So let me go through a couple of housekeeping and we'll get started right away. These are all live sessions, so you can do Q&A. It's on your top right-hand corner. Please ask a question. We'll try and get as many answered as possible during the keynotes. Secondly, this is being broadcasted in 16 languages. So there's a world icon button at the bottom. Feel free to choose the language of your choice. As I had talked in the first day, I can speak 4, but I don't want to confuse the system here. And of course, if you're confused, then there's an FAQ on the events page, and LF event staff is more than happy to help you out. So with that, let's go ahead and get started today in the morning and afternoon session in this, what I call, East Coast EU-friendly time zone. We have the most power-packed lineup today. And you don't want to miss this. So let's get started. First up, we have Matt Trifiro and Jacob Smith. Matt's the CMO of Vapor.io, and Jacob's the VP of bare metal marketing and strategy at Equinix. 2 leading companies and 2 thought leaders who have really changed the way we think about edge. In fact, all the way from clarifying what edge is and defining what edge is to how to implement and take advantage of it. So without any further delay, please take it on, Matt and Jacob.
Okay, great. Thank you so much, Arpit. Happy to be with you all. Matt, welcome to yet another State of the Edge presentation, yeah?
Yes, I'm excited.
Great. Absolutely. Okay, well, to get us started, because we do have a very packed day, I think everyone's excited about the full agenda. Gonna go ahead and get us started here, see if we can make the clicks move. Okay, so some quick introductions. So as Arpit said, my name is Jacob Smith, and I'm the VP of Bare Metal Strategy and Marketing at Equinix. I'm calling in from the Edge in Vermont, in rural Vermont. And this is where I, get to spend a lot of my time, but really enjoy interacting mainly, as you can see here, with developers and hardware, 2 things that we see coming together in the State of the Edge report that we're going to talk about today. Matt, quick intro from you.
Yeah, sure. Thanks, Jacob. So my name is Matt Trifiro, and I work for an edge infrastructure company called Vapor.io. I'm the Chief Marketing Officer there, and I co-chair the State of the Edge project with my good friend Jacob.
Excellent. Good deal. Okay, so what we're going to cover today is the 2021 State of the Edge report, which is a collaborative and open source report that we've put together now under the auspices of the Linux Foundation. I'm going to try to click through. I'm having a little trouble on the click. So Matt, do you want to do it for me?
I will.
Great.
There we go.
Okay. And the word collaborative is super important to everything that we do at the Linux Foundation, but especially to the Edge. And this is truly a team effort and a volunteer effort in many cases. So by preparing this report under the LF Edge and the Linux Foundation, we have subscribed to an open methodology, and that means that all are welcome to participate and to join us as we prepare this kind of content. But this year was especially exciting for me because we had 4 different expert authors, which you'll hear about as we present the content, as well as just an awesome collection of member company volunteers and other people who joined to help us make the report possible. So we get to take the credit here on stage, but it's really due to these people who worked so hard over the last few months. So just the other day, I think it was on Wednesday, we published the 3rd edition of the State of the Edge report. This is now, as I said, under the LF Edge banner of the Linux Foundation. Really excited about that because it really reinforces what I think is probably the most important part of this report, is that it is neutral, vendor neutral, collaborative, and community led. And the purpose of that has been clear from the beginning of the very first report, but it's even more true now. And I think as we go through and look at the edge ecosystem, we can see examples of that collaboration everywhere. All right, so what the report looked into this year was 5 different topics. The first is really building upon last year's report. You can find each edition up on stateoftheedge.com. But last year we did a bottoms-up model of the edge computing ecosystem to really see what's the forecast look like? Where's the money, as you might say? And so we built upon that this year. And so Matt's going to talk about that first in a minute. The next was with critical infrastructure. So obviously Matt and I both work for companies that are heavily involved in this, but it's a really interesting space right now. So I'll touch on that. Edge hardware, also networks and networking, and then of course, software. So this is how we spliced and diced the report. But we're going to kick it off first and foremost with the money. Matt, go for it.
Yeah, good morning. So as Jacob mentioned, the entirety of the 2020 report, which is also available for free at stateoftheedge.com, covers the model that Phil Sheeb built for us in quite a lot of detail. And he updated it this year to include additional information, primarily the impact of COVID in accelerating a lot of the factory automation and remote operations that we expect to see. And we've predicted 800 billion of computing infrastructure spend. And what we mean by that is the data centers and the IT equipment required to run the edge workloads. So that is data centers on both sides of the last mile network, but for servicing particularly edge workloads. And it's driven by 2 things. One is, where do we see the growth happening globally? And you can see in this slide where most of the growth is happening in Europe and Asia Pacific and North America, but certainly extending into South America and Africa. And also bottoms up again from each of the different segments. So the analysis looks at the segments, it looks at the regions, it predicts growth of applications driving the growth in those segments, and then predicts the IT compute workload that is required to support those, and then does estimates the power footprint. Those of us in the data center industry measure the size of data centers by the amount of power they can rectify, equipment they can rectify. So a 1 megawatt data center has a capacity for a megawatt of equipment. And then there are some reasonable ratios of converting that into dollars, and that's how we get to the $800 billion. It's a forecast. We don't necessarily think it's right, but it's a discussion, and it's certainly an interesting discussion, and it's useful to do these predictive models and update them over time. I'm also going to cover critical infrastructure. So you look at critical infrastructure. These are the data centers, but they're also the towers, the small cells, the fiber in the ground, and the other sorts of things required to drive edge computing. And a lot of what's happening, excuse me, if you think about the internet, it sort of started in 2 locations, May West and May East. And over time, it's primarily expanded from the core out, sort of like a root growing underground. And so you have the very thick roots where it originates, and then they get thinner and thinner and thinner. And the internet today, that if you think of it like a backbone, the backbone kind of ends at the key IXP points, the internet exchange points. And those are in major cities typically. In the US, for example, there's about 40 of them. And a lot of those are actually in the same city. So there's really about 20 places where there's this major confluence of networks where networks can peer and exchange data, which is very important to the internet. And as peering and data exchange has grown and the number of IXP points have grown, you're seeing this like flattening of the internet, where traffic doesn't have to go back to a core or to some far location to get where it needs to go. It can actually just be exchanged more locally. And what's happened, one of the major trends is this backbone, if you think of it, is being extended out from these tier 1 cities into these tier 2 cities, into these tier 3 cities, and also within these cities closer to the edge of the access network. And what that simply means, it allows 2 networks. If I'm on Verizon and Jacob's on T-Mobile and we are exchanging data, it could actually go through a facility that is in the same city we're in rather than being backhauled to some major city, which lowers the latency and all kinds of great things. So these edge exchanges, ways to cross-connect networks are emerging and driving a lot of the critical infrastructure around new fiber routes and new neutral facilities. And what's also interesting is the shared infrastructure. So you know, the thing about the edge is there's not enough power or physical real estate for every company, every cloud company, every telco to actually locate all the servers they're going to need. And so what we need is we need shared infrastructure. We need to be able to share a lot of the fiber and share a lot of the data center capacity and street side cabinet capacity in order to allow for these complex workloads. And what's also nice, since there's going to be a lot of these data centers in the field, is we can deliver a new kind of resilience in workloads by using high availability software techniques like from Kubernetes and so on, where a workload can be in one location and if something goes wrong, it can switch over or fail over to a nearby location with very little disruption. And that's reducing the space and the cost of all the IT, the data's critical infrastructure, because you don't need, you know, the same level of mechanical redundancy. Jacob, you want to take over edge hardware?
Yeah, absolutely. So like I said, I'm sort of a hardware nerd, but not because I have any right to be, just because I love it. But what we're seeing right now in hardware at the edge is a lot of diversity. Obviously, it's a fascinating time for silicon and also for specialty infrastructure that's emerging primarily around how to process more efficiently, like Matt said, such an important part of the edge, and how to do it with more flexibility and speed. And so we're seeing investments, the report talks about in open hardware, sort of form factors and ways in which infrastructure can be secured and distributed. And also this idea and the promise that we've seen originate in the core cloud around specialty, say offload, smart NICs, this kind of thing, moving to the edge, where they're really, very relevant, especially with programmable infrastructure. So Matt, let's move on because we have a couple more that we want to cover. So you grab network.
I'll cover this one quickly. Yeah, so the networks, both the networks in the ground and the wireless networks are changing quite significantly. The build out of 5G, but also the CBRS spectrum and the ability to have private wireless and unlicensed spectrum is driving a lot of expanded low latency edge suitable networking. The economics are changing because again, we have this shared infrastructure, but not just like shared towers and radios, but shared compute, right? We can put multiple virtual machines on a single piece of hardware and run network function as well as typical application workloads. And as I mentioned earlier, there's new kinds of interconnection peering happening out at these edge locations, and this is driving a lot of the innovation in networking at the edge.
Yeah. In many ways, the genesis of the internet from a networking standpoint and interconnection is defining how we look at things. But in other areas like hardware, we're thinking about more open, more flexible, and obviously a lot of this is being driven by software. So Matt, if you could click once more. Software, I think, is one of the more interesting parts of the report this year, in that it's matured so much, right? The CNCF and its work over the last few years, but also the projects at LF Edge and other places. The community aspect of solving problems has really accelerated what, a few years ago when we published the first report was really a promise and a hope to a reality in, real deployments that are orchestrated with amazing complexity. And that's really making the edge more accessible and more of an innovation spot, a business driver. One of the things that the report pulled out that I thought was fascinating was the role of hyperconverged solutions and marketplaces that are extending from the cloud, making it easier and to service customers who want the benefits of the edge, right? And so that's a real change that we've noticed over the last few years from the reports, but especially this year with as Matt said, the focus on accelerating transformation from COVID can't be understated. It's put a lot of reality into a lot of deployments that previously were more forward-looking.
Want to cover this with Jacob?
Yes, please. Okay, so I'm just going to say once again at the beginning, I mentioned how important it is to have a team and involvement from the community. This is meant to be a way to reach beyond our own circles and find information. There's a variety of projects that the State of the Edge pushes forward, including a glossary, which is in the report. and also a landscape, which is ever shifting. And so if you have questions about it or you see things that are missing, come to us. We're the co-chairs of the working group, but also to the State of the Edge project and get involved. I mean, it's really that easy. Is to come and add your voice, add your perspective, and we really welcome it and think it's really critical to the evolution of the edge.
All right, I guess to close this out, and I guess we have time for questions, Arpit, if that's when you want to do that.
Yes, please.
Yeah, so please download the report, stateoftheedge.com. All four of the reports from this year and prior years available free of charge, just for downloading on the website.
All right. Hey, this is excellent. In fact, some of the questions were all around where do I download it? So LF Edge, State of the Edge, the links are all there. I think there are several questions, Matt and Jacob, around this whole notion of data centers and equipment moving from core to edge to sort of, further down the network. And in that scenario, what footprint and how much of the footprint do we see in either micro data centers where there's like 20 to 200 kilowatt facilities, and effectively give us some ideas on sort of the power management, if you may.
I mean, so maybe this is actually a little bit of both of us. So obviously these large regional data centers are getting larger, and there are new ones that are being built. And there are new regional data centers that are being built in not just tier 1 cities, but tier 2 cities and tier 3 cities. I mean, if you go to a tier 1 city, there are big data center companies like Equinix and Digital Realty and CoreSite and so on. You go out to a tier 3 city, it's like Bob's Colo. And that's difficult for deployment because you don't have a standard deploy, you don't have all the certifications and things. So a lot of these big data center companies are pushing out farther to put these, well-run certified data centers out in the field. But also, like what my company does, is deploying these micro data centers. And these are, range from 20 kilowatt street side cabinets to, 200 kilowatt, school bus size deployments. And so it's a real mixture of these. And I think from an edge perspective, an edge microdata perspective, we see between now and 2028 about a megawatt per city in the US, like the top 50 US cities.
Cool.
Yeah, absolutely becoming regionalized. I think one important point Matt makes is that we're seeing, and the report kind of speaks to this, customers looking for ubiquity and looking for deployment as everywhere as possible. And that's of course extremely expensive. So we're seeing some of the things pushing out, and I think we see some of the major cloud providers as well coming in, less on the the infrastructure side, but more on the software and marketplace side.
All right, very good. Hey, that was very informative, and I think if the registered folks have not downloaded the report, absolutely go for it. This is an amazing set of collateral. But more importantly, I would say, participate in the project, State of the Edge, collaborate, help. This is a community-driven thing, right? So it's all volunteers, and we are all collectively trying to solve some of the hardest problems that are not differentiating. Okay, nobody gets more money by calling it far edge, thin edge, thick edge, compute edge. We all benefit if we standardize on vocabulary. We all benefit if we kind of focus on the plumbing. So thank you for your leadership, and thank you very much.
Oh, great pleasure. Thanks, Arpit.
Thank you for having us. It's a pleasure. Thanks, Arpit.
All right, very good. Okay, so this was excellent. And now we have a very exciting presentation. As I mentioned in my opening keynote on Wednesday, the industry, the telecommunication industry, the cloud, the IoT, edge, all of these frameworks have moved to open source. 5G is a big enabler, edge is a big enabler. And I think what has happened is this plumbing layer, if you may, for a lack of a better word, this non-differentiated lifecycle management layer with 5G has really opened up multiple vertical industries. And all of a sudden, these industries can take advantage of 5G, they can take advantage of the open source software, and they can really benefit from the simplification, standardization, and all the innovation that has happened below. So one such industry is obviously, the broadcast industry, and who better to represent this whole concept and give us all the requirements than Madeleine Noland, who's the president of ATSC Systems. And she has great insights into what we as a community, of geeks in the networking and edge and software space should be doing to meet requirements that frankly have never been met in an open manner so far. So without any delay, Madeleine, please welcome and take it on.
Thank you very much. So it's such a pleasure to be here. As Arpit mentioned, what's happening in the open source community is certainly attracting some new verticals. And at the same time, the television industry or the television broadcast industry is launching a new standard which allows the industry to begin participating in this sort of heterogeneous network ecosystem that is developing in the world today. So what I'd like to do is kind of give you a quick introduction to this new technology called ATSC 3.0. It does have a better consumer-facing name for the television services. It's also called Next Gen TV. But ATSC 3.0 is the broad standard that enables much more than just television using this wireless data delivery network, which we know as the television airwaves. So there's a lot of information in this slide deck, and I've only got my short 15 minutes or less, so it's going to be a little bit of a whirlwind for you. But believe me, the fire hose is going both ways as the television industry experts are learning more and more about open source and core network concepts. And hopefully we are going to give you a little bit of a fire hose treatment in terms of what's going on in the broadcast industry. So we'll give you a quick introduction to ATSC 3.0 or Next Gen TV, a quick understanding of what's going on with the deployment in the US as well as in non-US regions, and also about ATSC 3.0 as a platform. And finally, I'm going to be talking about core network for broadcast, which is a new concept in the broadcast industry, but certainly a well-known concept for everybody on this call. So a little bit about ATSC. We are a standards development organization. We have roughly 140 members that really represent the entire ecosystem of the broadcast industry, from the consumer electronics manufacturers like Sony, LG, Samsung, and the other names you know well, as well as the broadcasters, NBC, ABC, and many, many equipment and solution vendors as well. And we're also seeing members coming in from the telecom industry. We have Qualcomm and SK Telecom and a few others that are sort of bringing that sort of expertise into ATSC. Amazon Web Services, Hewlett Packard Enterprise are all newer members that are getting involved in the system today. So ATSC 1.0 is today's over-the-air television standard. And for those of you who remember rabbit ears and all of that, this is free over-the-air television. But what it really represents is an infrastructure that is nationwide, in fact, worldwide, of high power, high tower, highly resilient systems that deliver data to homes. And ATSC 1.0 was designed for television, and it was designed for fixed reception on high rooftop antennas. And thinking about what that was like, well, that was back when we had Windows 3.1. We had 12.2 kilobits per second in our modems, which was great, right? We had analog cell phones, which I think you needed a crane to carry around. And we had VCR tapes, and we had ATSC 1.0. So as you can imagine, it is time for an upgrade. ATSC 3.0 is a major upgrade over ATSC 1.0. First of all, the physical layer is more flexible, more configurable, and it's currently the world's most efficient one-to-many transmission system. It gets closer to the Shannon limit than any system out there today for one-to-many distribution. The transport is now IP-based, and that may sound like, well, of course it is, but in the past, television transmission systems have been based on MPEG-2 transport system. This is the first television delivery system that is based on Internet Protocol. Of course, we have to have better TV, better video, better audio, better applications, accessibility, and advanced emergency messaging is always a key core part of broadcasters' service to their communities. But we're able to do for the first time in a much more efficient manner, data casting. In other words, if we're delivering IP data packets, what difference does it make whether those are streaming video and audio or something else? Map updates, software updates, who knows what digital signage, smart agriculture, connected cars, all kinds of things for the future. And one of the more important things that the architects designed into this system is that it is convergence ready. So the ATSC designers imagined a heterogeneous network system where different data will be provided using the sessions on the best network for the best purpose. So it's actually designed to be easily interoperable with other IP data delivery networks, which could be Wi-Fi or Bluetooth or the internet, LTE, 5G, etc. So data casting as a service is actually one of the big benefits to broadcasters for this new system. So ATSC 3.0 is a large digital data delivery pipe, wireless. There's new single frequency network capabilities, which enables either better reception or more capacity or some combination. And what it allows is terrestrial broadcasters can start working or competing with other data delivery networks in the sort of data delivery commodity market, if you will. And it's mostly suited for cases where there's a one-to-many use case. So in other words, where many, many devices need to get the same data. So ATSC 3.0, it's not just about television anymore. A little bit about the deployment. What's happening in the United States right now is that television broadcasters in 62 of the 200-odd television markets have announced that they will transition to ATSC 3.0. Now, this is a voluntary transition. The transition from analog to digital was a mandatory transition, but this one's voluntary. What's exciting about these 62 markets is that it may seem like a smaller piece of the 210 all in. However, it includes the top 40 of the markets in the country. So when we get those 62 markets launched, we will be reaching roughly 75% of US households. What you can see here is the progress of this launch. Right now, we're at about 25% of US households with roughly 100 television stations on the air with ATSC 3.0 services. Also, what's happening in the device market, again, focusing on television for the moment, the Consumer Technology Association released some statistics and some research about their expectation for the uptake and sales of next-gen capable television sets. Because honestly, the broadcasters aren't going to launch this new system, which enables all these data casting, if we can't do television. And we can't do television if people don't have TVs that do it. But they're looking at hopefully having roughly 24 million television sets in the marketplace by 2024 that have this capability. And more recent research suggests that these numbers are probably too conservative. We think we're going to beat these numbers by quite a bit. And in addition to televisions, we have some set-top boxes that are out there, the Zapper Box and the HD Home Run Connect, as well as chipsets that are coming on the market from MediaTek and more. And low-cost converter boxes are also being explored for those consumers that don't want to buy a new set-top box and they don't want to buy a new TV. They want their old TV to connect, and a low-cost converter box can be a solution. And this device market is going to inspire the broadcasters to, beyond those 62 markets, to get on the bandwagon. There's also a lot of international interest in ATSC 3. South Korea actually launched the service in 2017, and they are currently reaching roughly 75% of households in that country. Canada is exploring ATSC 3. Humber College in Toronto is developing plans. The Communications Research Center in Ottawa is participating heavily, and the North American Broadcast Association is also forming working groups around this technology. The Brazil SBTVD Forum, that's their SDO, is evaluating ATSC 3.0 along with other proposals for their TV 3.0 transition. And in India, TSDSI, their telecom, is studying ATSC 3 and other technologies for broadcast traffic offload scenarios and direct-to-mobile services. And there are a number of other countries that have reached out, and ATSC is kind of organizing itself to respond to that outreach, as well as getting the standard documented in the ITUR documents. ATSC 3 is a platform, which is different from ATSC 1. With ATSC 1, we came up with the standard, we spent a lot of money, we deployed the standard, and then we did nothing to advance the standard more or less for about 20 years. That is not going to be the case with 3.0. We don't have the luxury to deploy something and sit on it for 20 years anymore. We have to be able to move quickly, just as others in this session are going to be describing. So ATSC is maintaining this platform, and we're excited about moving forward. And one of our big new initiatives right now is a core network for broadcast, which I'll get into in a minute. And as I mentioned, ATSC is envisioning convergence, where it's a 5G ready sort of convergent system. So you can imagine the concept of network slicing, where the broadcast transport system is part of that ecosystem. And it was designed so that it has many common components with the 5G system, not only at the physical layer in terms of the frame numerology, but also the IP transport and the W3C based technologies, et cetera. So ATSC3 can deliver audio, video, data, mobile to fixed and mobile terminals in large geographic areas, one-to-many communications, large number of terminals simultaneously. In other words, point-to-many point. But the broadcast system has traditionally worked where each broadcaster controls its own tower. And nodes don't make a network. So we got all excited in June 23rd of last year, we launched Nashville. We got 2 sticks on the air, 12 megahertz altogether, but that is not a network, of course. So all of you know the core network functions pretty well. And in order to explain to the broadcasters, I try to use the cell phone network as the example of what we're trying to do. And I know people are familiar with this already, so I'm going to skip over this. So why a core network for broadcast? Well, ATSC3 enables a nationwide wireless IP data delivery network, right? Well, actually, since the broadcast towers operate within one of 210 market areas, we in fact do not have a nationwide data delivery network. We have 210 little ones. So core networks are there to coordinate the data transmission among multiple transmission towers, and broadcasters can work together to form one or more regional or national broadcast networks, basically becoming broadcast network operators, if you will. So when you combine ATSC 3.0 as a standard with a core network, now we have a nationwide wireless IP data delivery network. So as you can imagine, the broadcasters are excited about this concept. That would allow them to offer data delivery services to national and regional customers, broadcast traffic offload scenarios to two-way network operators, backhaul services between towers, and much more. So the functions are pretty much the same. So even when we get all of our nodes launched, we still don't really have a network. What we really need is this kind of scenario, where we've got many, many nodes launched, and they're all connected by a core network backbone that allows us to operate in these spaces. So one scenario is this concept of traffic offload. So TSDSI is exploring traffic offload for India because they have 1.2 billion cell phones, and a lot of people don't have televisions. In fact, many, many, many people watch television on their phones, linear television. And so people watch this linear television on their phone, and the cell phone ownership and data usage is continually rising. So the concept is that when a lot of people are watching the same content at the same time, you could shift that content from the cellular network to the broadcast network. And the goal would be to improve the cellular network performance by moving some of the traffic onto the broadcast network. So India operators are experimenting with the 3GPP broadcast mode. I think it's EMBMS is what they have right now. I understand FEMBMS is also available. And they're also exploring ATSC 3.0. So we'll see what comes of that, but it's pretty exciting. So ATSC is actually standardizing a core network for broadcast. It's probably going to look a lot like an FEMBMS core network, where you have the concept of SIM cardless reception. In other words, we might have a downlink only. And what we have done is we've just formed a new technical work group called TG3S43, because we don't know how to name stuff. That's what we name things. And they're just in the early stages of the work. And what's exciting is that they're very interested in open source solutions, and they're very interested in the virtual network function architecture that was designed for 5G. So we're just getting in on the ground floor of this, and we are looking, to have experts come into the television groups to help teach the television folks about all these great and interesting new concepts. In summary, DTT broadcasters, in other words, digital television terrestrial broadcasters, are operating in a global ecosystem of converging networks, whether they admit it or not. Data session, steering, switching, and sharing, aka the ATSSS document, across heterogeneous networks can improve the spectrum usage. So we can use the most appropriate network for each given use case in a dynamic fashion. And ATSC3 currently is the most efficient one-to-many data delivery system in the world today, designed for TV and non-TV uses and for fixed and mobile usage, one-to-many downlink, and designed for convergence with other data delivery networks. And a core network for broadcast enables broadcasters to efficiently participate in the global converged network ecosystem. So TG3S43 has been formed, and they're expected to explore open source solutions and architectures for the new broadcast core that's being developed.
All right. Thank you, Madeleine. That was very informative, and I'm so excited about this. The interesting thing that I picked up was that the television industry has come a long way, since the early days, and convergence is the key word. In fact, not trying to reinvent technologies, standards, and or code to just satisfy the broadcast industry, but to utilize what the rest of the ecosystem has done. So I think that one is very encouraging for the people. Again, if you have questions, there's a Q&A button on the top. Feel free to ask questions. There are a few that are coming in. The first one I would probably like to ask is, as an end user, vertical industry, right? I mean, we heard from the US government yesterday, DoD. We've heard from several end users, telcos. We've heard from the cloud ecosystem. We've heard from gaming and other edge vertical markets, manufacturing, etc. So as an end user, and we are excited that this working group has been formed. What would you request people on the call are 5G experts. I mean, a lot of them work on a project called ONAP, which does 5G network slicing. They work on ORAN SC, which does kind of the open RAN on the 5G side. They work on edge, etc. What would you sort of say as a call to action in terms of helping out, because these are standard activities, and I'm assuming once standards are formed, you would push them down to the open community to upstream and open source and code it so that it meets the requirement. I'm assuming we're just following that simple model, and we're not going to develop code just for the television industry. Is that a correct assumption?
Yes, and so thinking about the question, what is the call to action? ATSC is in the same, has the same attitude as what you just described. We do not want to reinvent the wheel. Television broadcasters are new to the core network concepts, and the core network concepts are so well developed in this 5G, 4G cellular world. And ideally, we don't write very much new standard. So the best thing that could be helpful and move the ecosystem forward would be to ensure that ATSC is using what exists, so that so we don't start from scratch, which would be, of course, silly. But among the television engineers, we have a tremendous number of really, really smart people, but there is a bit of a learning curve. So to ensure that these engineers understand what exists today, how it can apply to the television broadcast system, so that we can clearly delineate any gap analysis, even if there is any. Potentially, the whole thing could be a recommended practice that explains how to use the concepts described in 3GPP standards and apply them to the television core. That's possible. But what we need to do is we need to really completely understand what's available so that we don't reinvent things that already exist. And to the extent that folks are interested in participating in ATSC, either as members or as guest presenters, that would be tremendously helpful to the system, so that we can be sure that we're working on something that's very well aligned with what this community is interested in working with.
Awesome. And there are a few more questions. I'm sure one of this question may have created maybe a new use case for you, or you may have already thought about it. But someone's asked, could one application of ATSC be to broadcast firmware updates to IoT devices in the field, so that you could probably have a network of IoT devices right there, and if so, would each IoT device need its own ATSC receiver like an OTT box, or is that just a software with a hub? But in general, have you thought about generally, the billions of connected devices that will exist in the field from an edge perspective?
Yes, definitely. Firmware and software updates would definitely be something on the radar, as well as, for example, large map updates that might be going to car navigation systems. These are the kinds of things that are perfectly suited to the one-to-many system. We, in fact, were having conversations with a major social media platform that is updating their app on phones. And currently they pay for data to be sent over some network, whether it be a CDN, Wi-Fi network, or what have you. They're thinking that, well, if the broadcasters are planning to compete in sort of the commodity market of data delivery, can they save us money by us using their network to deliver this data rather than another network? And the answer is the broadcasters think so. They think that they're going to have a great price because it's a one-to-many system, and they think that they're going to have a great service level because the system, the broadcast television system, is extremely resilient. I mean, this is the emergency messaging community, and when hurricanes hit, television stations are up. So it's extremely resilient, high service level. But the question is, how is that business math going to turn out? Because you're right, you do have to have an ATSC 3.0 tuner in the device. So how much does it cost to put that tuner in the device versus how much can I save in data delivery costs? And the answer is TBA. You could also envision, though, that if some of these devices are in the home, that you could have one ATSC tuner receiver in the home, which could act as an ATSC 3 hotspot. And then it could deliver IP packets over the home network. So that's another possibility for some of these IoT devices. But for those kinds of devices that are on the move, like cars and cell phones and other mobile devices, then thinking about having the tuner in the device itself is probably something that's worth considering.
Beautiful. That's a great wrap. But again, I really want to thank Madeleine for providing these insights. I think the open source community is really excited of helping out the ATSC and the broadcast industry. So thank you very much for taking the time to talk to us.
Well, thank you. And everyone is invited. This is kind of a green field right now. So it's a great time to get in on this project. And we welcome anyone who would like to be involved or has questions. Thank you.
Thank you. All right. The next speaker is one of the very active participants in the open source world. He's the CEO of a startup called Aarna Networks here in the Bay Area. And he's going to talk about an interesting concept on how open source gets pulled together. And how do we look at it from an end-to-end perspective? Because remember, disaggregation will require reaggregation and integration at the end. So please welcome Amar Kapadia.
Thanks, Arpit, for that introduction. Hi, everyone. Let me just give a quick introduction on Aarna Networks. Aarna Networks is a startup, and we are creating an open source platform for orchestration, management, and closed loop automation of 5G networks and edge computing application. The and is important. We believe there's going to be one unified edge, and therefore you need one unified management solution. So let's talk about the problem that we are solving. With 5G and edge computing, something interesting happens. Everything becomes a piece of software. Other than the radio, everything is software. What that does is that the stress on network service or composite application management explodes by about 1,000,000x. And what does that really mean? So assume you have 1,000 edge sites, and assume you have 200 applications that, when combined with network slicing, go up to 1,000 application instances. So, and assume that you are running all of this on Kubernetes, edge, core, and public clouds. So on the orchestration, now, if you're trying to do it with the current methodology, you'll have 1,000,000 Helm charts that you'll have to modify. You'll have to log into 1,000 Kubernetes master nodes and run a few million kubectl commands. Clearly, nobody is going to do this. When it comes to lifecycle management, something similar, you will have to connect to 1 million application endpoints, whether it's GUI or APIs, because typically applications and their management systems have a one-to-one relationship. Or you'll be running a bunch of Ansible scripts 1 million times. Again, this is just simply nobody is going to do that. That's not feasible. When it comes to service assurance, to solve problems, again, you'll have to connect to 1 million management endpoints. You'll be looking at 1 million dashboards, and human beings will be solving problems based on tickets being opened. Again, just simply not viable. So that's the problem that we are attempting to solve. It's an ambitious problem. Fortunately, we have a lot of help from open source. So the solution is we are using Linux Foundation's ONAP project for intent-based orchestration, lifecycle management, and real-time policy-driven closed-loop automation of 5G network services and edge computing applications. Let me explain what all of that means. That's a lot of jargon thrown in. So what you see in this diagram on the left is at the bottom you have the cloud, or technically you can call it the NFVI, Network Function Virtualization Infrastructure. So that's going to be industry standard hardware with Kubernetes on top, and maybe platform services like database as a service, etc. So you have these. On top of that, you have the applications. Applications could be of different types. They could be cloud-native network functions, 5G core, 5G RAN, virtual firewall, SD-WAN, so on and so forth. They could be arbitrary cloud-native applications, drone control, robot control, 360 video, etc. Analytics, video surveillance, radiology anomaly detection, and platform services like EdgeX Foundry, Amazon Greengrass, Azure IoT Edge. So what this management solution does is step 0, it registers all the Kubernetes clusters, whether you have 1, 10, 1,000, 10,000. Then it onboards the applications. Then the designer can create network services or composite applications, and then do intent-based orchestration with day 0 configuration. So this is all zero touch, completely automated. Once the initial orchestration happens, the day 1, day 2 lifecycle management configuration is automated through the system. And after that, the management system monitors these applications for fault management, performance management, etc., and then makes corrections automatically by running all that telemetry through a big data or an AI ML pipeline without involving human beings. And that practice is called real-time policy-driven closed-loop automation or control loop automation. You'll hear both words. So that's the solution we are building. We're taking some components from ONAP. We're taking a particular component from Intel's openness and packaging it all together. We will add value on top in terms of network slicing, non-real-time RIC for ORAN, NWDAF, which stands for Network Data Analytics Functions for the 5G core. In terms of our open source participation for 2021, we are involved in ONAP in a variety of activities, Linux Foundation networking demos, and Linux Foundation Edge Akraino. I'm going to spend the rest of the time on a very interesting and new development, the end-to-end 5G super blueprint. We are actively involved with that, as Arpit mentioned, and I'm personally just super excited about that. So what is the end-to-end 5G super blueprint? There was realization in the community that all the ingredients required for an end-to-end 5G blueprint already exist. They're already there in Linux Foundation. And there are also some existing blueprints or demos that are doing parts of this. So why not just combine all of this and create a super blueprint, as it may, and solve this problem holistically. So you have what I'll show you in the next few slides, what components we are taking from all these projects and how are we leveraging existing demos. My personal prediction is that this new blueprint is going to democratize and dominate 5G. I think you will see it in production, maybe second half or definitely in 2022. And what's interesting is this is not just an open source software project. It's an open source solution project using production-ready open source software. So let's dive into that a little bit more. So this blueprint has three stages. Stage 1 is going to be Q2 of this year, then Q3 of this year, and then Q4. In the first stage, we are going to show 5G core with edge computing applications. In the next stage, we will do end-to-end 5G. And then finally, we'll do 5G with O-RAN. And in the middle phase, we will also do end-to-end network slicing. So I'll show you the components in the next few slides. The value is obviously fully disaggregated, open source, 5G with edge computing. And in the last stage, we will also show O-RAN. The use cases are 5G fixed wireless access, private 5G, edge computing, IoT, and ultimately full public 5G networks, including voice services. So this is what the first phase will look like. On the top right, we will have ONAP and an openness component running on Kubernetes, which will come from the Anukit project. That is going to onboard and orchestrate the Magma project. That's a recent development. In case you haven't followed it, the Facebook Magma project is now part of the Linux Foundation. In addition to that, the ONAP and openness combination will onboard and orchestrate edge computing applications that come from the Akraino, one of the Akraino blueprints. Magma will run on Anukit's Kubernetes reference implementation as well, along with a variety of additional Linux Foundation projects for SDN controller, for virtual switching, storage, data plane acceleration, etc. Now in this phase, we will use a Gnode B and a UE emulator to show the system. So that's going to be the first stage. The next stage looks very similar, except that we will replace the emulators with a commercial Gnode B. And that will be, with that, we'll be able to show an end-to-end 5G and edge computing system. Even though with a commercial RAN, we will not be orchestrating it, but we will definitely be managing it because the combination of ONAP and openness can definitely manage PNFs at the same degree as VNFs or CNFs. And in the last stage, we are going to replace the commercial RAN with O-RAN SC, which stands for O-RAN Software Community Software. And with that, we will have the RU, the DU, the CU, and near real-time RIC, all managed by ONAP. And in this case, ONAP will take the role of an SMO, the O-RAN SMO, Service Management and Orchestration, and will talk to O-RAN over interfaces such as O1 and A1 for complete fault management, performance management, configuration management, and communicating with the near real-time RIC. So hopefully that gives you a good flavor of what we are doing as a company and this brand new 5G super blueprint. And I would invite everyone to join this blueprint. It is, like I mentioned, open source. The more people we have, the faster we can execute and the richer the blueprint can be. Thanks, Arpit.
All right. Excellent. Thanks, Amar. That's very, very informative. Again, if there's questions, please feel free to put them in the Q&A on the top right. There are a few coming in. In terms of collaboration and things like that, where are you expecting, your and other similar companies from your perspective, where are you expecting this work stream or Is it part of LFN, LFEdge? I mean, there's a lot of Linux Foundation, and even outside Linux Foundation. I mean, this is just not like a book-ended solution, right? This is kind of an open source based end-to-end stack, if you may. Where would people come in? I mean, is it part of any release? Is it part of any work stream, demos? You know, where are you thinking of contributing this?
So there's in Linux Foundation networking, there is already an existing cloud native 5G demo. So it's part of a demo project. So that project will be expanded to now handle this 5G super blueprint as well. And what you see is you see a very interesting set of contributors that'll come together. So people like us will come together from the management side. You will have companies that'll come together. There's a variety of Magma contributors who are going to work on this from sort of the 5G core point of view. You will have people joining from AnuKit who will bring the NFVI perspective. And I think that, to me, shows the power of open source, where you can have people with diverse skills come together, which no single company can do. Companies tend to be more homogeneous. And here we'll have experts all the way from management side down to the hardware and people thinking about SRIOV and DPDK. So that's how we'll be doing it. It'll be completely open governance. I mean, it's Linux Foundation. I don't have to say it, but it'll be completely transparent, open with open governance. So anybody is free to join and start helping.
All right. There's a few more questions. Some on the dates that you had proposed. I think you may have gone through very quickly. So that's kind of on the dates. And I think the other question was in the third stage, you know, you said commercial RAN and ORAN. I mean, you specifically meant the software portion of it, because there's still the commercial RAN vendors who support ORAN, right? So I think just clarification on those two, please.
That's a good clarification. Sorry, yeah, I misspoke, yeah.
Yeah, and the dates would be phase one is you're thinking Q2, Q3, Q4. So every quarter, like any other. Okay, very good. Thank you very much. I think we may be able to take one more question. How do you see, you know, now that the MEC and the cloud come together, how do you see, you know, ONAP driving the enterprise market along with the RAN as well? There was a question like that. So could you specify on that, specifically now that ONAP is all cloud native, right, with the latest G release?
Yeah, and that's a really good observation. There's a brand new effort I started a few months ago, ONAP for Enterprise. And what's been interesting is for us in the community, it's always been obvious that there's nothing that ties ONAP to networking or to telecommunications. It's a very flexible and open sort of a platform. And I'm glad to see that effort. That's another initiative. It's a parallel initiative to what I just mentioned. It's in the ONAP community. And that's going to see how ONAP can be used for the enterprise. And I'm giving my personal belief at this point. My personal belief is that there should be no difference between a cloud native network function and a cloud native application. So whether you are doing network services based on CNFs or composite applications based on CNAs, from a management or an ONAP point of view, they should look identical.
Very good. And I think that is the power of abstraction and standardizing. Now, clearly VNF, CNFs, and in the telco world, clearly there's a lot more standardization and APIs that have been standardized, right? Versus in the enterprise world, we're still getting there, given that, you know, it's data centers and it's still, you know, proprietary inside the data center, especially in the large companies. So anyway, great questions. And again, thank you for your insights. Again, encourage everybody to join and participate. I think there's a lot of community interest on this as well, because I think you heard from several end users, right? I think Madeleine talked about it just recently on, you know, how can they pull it all together. Yesterday, the DoD and JMS talked about how they can use, you know, something at this level. Clearly, you know, we have huge interest in making this happen. So thank you for leading this effort, Amar. Thanks a lot.
Thanks, Arpit.
All right, so moving on to the next presentation, we have the CTO of Tech Mahindra, Manish Mangal, who has joined us. As you know, Tech Mahindra is kind of one of the leading SIs and you know, a global player, and they have a very broad vision of what's happening everywhere. And so, you know, it's our privilege and we are very excited to have Manish sort of talk about what he sees that we can all learn from. So please welcome Manish Mangal.
Thank you, Arpit. Thank you so much for the opportunity. It's an honor and a privilege. You know, what a great 3 days this have been. I mean, the amount of conversations that we have seen in the last couple of days, the great set of presentations, it's been just phenomenal. I just want to congratulate you, Arpit, and the entire leadership team at the Linux Foundation to be playing such a critical role in driving this ecosystem. And like you said, you know, we have one of the privileges to be a global player is to be able to have a good visibility as to what's happening around the world, and being able to help play our pivotal role in making these technology transformations real. So I'll start sort of saying is that we bring a bit of a different perspective. You know, there are so much of the technology that is changing these days, and that's a fantastic thing for industry. Our purpose in life is to really drive the realization of those technologies into the real world fields as fast as possible. And one of the things that we have been on a mission is, while traditionally it used to take 12 to 18 months for any new technology to get adopted into an operator's network or an enterprise adoption to be able to really take advantage of it, how do we shorten the cycle? How do we get the technologies much faster implemented, operationalized into a real world, and really allow the new way of building, operating, and optimizing networks? So we kind of reinvented ourselves. We said that the role of a system integrator from a traditional perspective is really the role of the past. Things are going to change on a continuous basis. The world really needs a continuous integrator that can really help integrate newer technology at a faster pace. Hence, you know, we ourselves call as a continuous integrator, not a traditional system integrator anymore. So with that insight, what I will share with you today, my perspective around how we are seeing some of these technologies coming together and what it means to really create the right environment for them to be adopted. So with that said, let me first start with the fundamental premise that we are operating under, which is really the network and the role of the network has drastically changed and is changing. You know, we started with network as a connectivity infrastructure, right? Whether it was a voice service or a basic internet access, you can relate it to 2G, 3G, or even 4G technology. It was all built around how do I give a connectivity to the user. Then we kind of evolved and said, it's not just about the connectivity. The network is a platform. And more importantly, it's an open platform that allows us to do two things: disaggregate the functions of the network that makes the operations and the cost of the network better. At the same time, allows the exposure of the network functions to be driven to the third-party applications for them to build it, right? And we saw a complete transformation of the industry as 4G really became a platform, and the Ubers of the world, the real applications that really came to use it became completely a phenomenal transformation for all of us. But that's great. Now where we are heading is really about, it's not just about creating a platform, but it's also about giving an experience. How can network play a much important role in creating the experiences for the end users? And I'll share why it's relevant, but we kind of see that network as an experience platform now going forward. And what that means is that the network is a distributed edge cloud, right? Every application that we are seeing is getting cloudified. What that means is that to maintain the capability of the network to deliver that kind of an experience, it has to be seen as a cloud, and it has to be seen as a distributed cloud that can go all the way to the customer edge and can basically drive experiences for the different applications as it's acquired. So to me, one thing is very fundamental as we look at how we at Tech Mahindra look to integrate various technology, deliver it for our customers, is really with the eye on how it's helping our customers enable the experiences for their customers. And that's really very, very key. And why it's key, right? With 5G, I think we are really stretching the envelope around two dimensions. One is around bandwidth, another one is around latency. Right now, bandwidth and latency has been known before. It's not a new concept. I mean, we have always had the idea of what it means to deliver the higher speed bandwidth and what's the latency required for voice versus data. But we are really going micro segmentation now. It's not about just voice and data, and internet access is just not one service, so to speak. These services that are going to be used inside the data connectivity, just there are plethora of those services. And I think what we try to do and said, if we were to really drive the network as an experience platform, it really needs to operate at these two vectors. One is the bandwidth, other one is the latency. And the capability of the network needs to support variety of the combinations of these latency and bandwidth, which is really the network slicing comes into the picture as a technology, right? But it has to be very adaptive, it has to be very seamless, and it has to become very, very integral part of how a services templates are created, the services templates are provisioned in the network, and they are operationalized so that the experience of those services can be delivered, and then monitor on a constant basis so that you have a service assurance and have a closed loop automation that allows you to make corrective and coercive changes as we go along. So we recognize that the industry is not about just providing internet access anymore. It's really about providing a plethora of applications. They all demand very unique and very differentiated experiences. And that's sort of a background from which we come from, right? And one very critical thing that's happening as part of that is a movement of the infrastructure itself. You know, one critical thing that we have, we hold very tightly is that around 60% of the consumption of the data is moving to the edge, which means that if you really want to deliver the experience that we are talking about, the infrastructure has to move around logically as well, closer and closer to the customer. And hence the whole idea of network edge that we all as an industry have been going, and Linux Foundation is doing a brilliant job in creating open source technologies with it, is very, very important. And it has to be. I'll just give you one specific example. What we are looking at from a manufacturing perspective, if I look at just an enterprise marketplace, is really to say, we are looking at a 3-tier architecture. There is a device edge that really is controlling all sorts of sensors and the devices that are in the market. And these could be consumer in the world of consumer and enterprises in the world of enterprises, right? And there is an enterprise edge. And this edge would sit into the network or in the prem of the enterprise. But this is really where your application experience, your application functionality, your capability, intelligence, all of that is being housed. And then you have a cloud, which is really a brain and the center from which all of your management happens, right? So a 3-tiered architecture is really what's starting to shape up as something that is real, something that needs to be operationalized, and something that needs to become so seamless that some of the applications may have to be hosted all the way to the device edge. Some of the applications needs to be hosted at the enterprise edge or the network edge, or some of the application has to be hosted in the cloud, right? And this has to be done on an application by application basis so that the experience again for them can be managed as it's expected. And this is where we kind of come in and say, that sounds like a very complex problem. There are too many technologies that are attempting to solve. Some of them are in a niche specific type of areas, some are in a broader way. But what does it take to operationalize something like that is where we kind of come from and say, it's not just a straightforward game plan to say, let's put just one hardware here or one software here. It's really about a hybrid environment, right? The world today exists. A lot of the new container native technologies that we are talking about are not going to be overnight replacing everything else. You know, we started from the world of a physical network. We are now in a what we call as a sort of a virtualized world. You can call it semi-custom, but it's really a virtualized open network where really we have segregated the hardware from the software. And now we are moving more into the container native, cloud native networks. The thing with this migration path, if I may say that, is this all have to coexist. We are not replacing everything overnight, and that really is where, when I talk to our customers globally, their number one challenge is, how do I take this new technology, which I totally understand is a great benefit, great value proposition, but how do I get it inside my network? How do I coexist with what I already have? And how do I create a transformation journey so that I can start to migrate over my existing capabilities that may not give me the functionality that I want, like the cloud native, container native flexibility? How do I start moving workloads more and more into the new architecture, new platform? And it has to be done as a transformation journey. It's not I turn the switch off once and then turn the switch on the other one. And that's where I think we have been spending a lot of time in our world to give our customers a view to create that roadmap, create that transformation plan, create that ability to coexist while not impacting the experiences of the customer that absolutely are critical to deliver from all KPIs perspective. And hence we created what we call as a NetOps.ai. So NetOps.ai, from our point of view, is really an automation platform, which really manages the life cycle of a network from an end-to-end perspective. Right? There are multiple layers of the life cycle management. There's an infrastructure management that has to happen. Then there is an experience, the customer experience, and the services experience that has to happen. So where we looked at and said, we really need customers a point of view in terms of how they can actually create this end-to-end environment for automation and multi-cloud orchestration. And that's something what is what I'm depicting on the slide right now, where you would see that below you have a bunch of different domains. I mean, you've got radio networks, you have got edge networks, transport networks, core, and all of that. You've got individual domain managers who are very good at managing the functionality, the performance of those domains. But how do I effectively give an operations cockpit, a single pane of glass to the customer that allows them to really manage the end-to-end life cycle of a platform, right? It can start from a plan and design and build phase on the left side, which we really term as the CDF functionality. It's a continuous process of planning and designing. It's not a one-time event that happens and goes away. So there is a whole module that we have built around on a continuous basis that implements the planning function. And in some cases, we have actually reduced the planning time by 70% by automating a lot of functions inside that. And then you have orchestration, the service orchestration, which really says, how do I bring in the right software on this network? Infrastructure could be hybrid infrastructure or any form of a cloud infrastructure. And that's where it could be a container native, or it could be OpenStack, or it could be VMware. It's sort of an infrastructure underneath it. But how do I bring a variety of different software on top of it and manage the life cycle of it in the form of a service orchestration? And then the service assurance, which is most important thing to make sure that whenever I deploy any network functions, the performance of that can be managed. And especially with the observability framework, right? Where we are looking at not just monitoring the network, but also observing it, how it's doing, and course correcting on an automation basis. And then the last function is really about continuous insights and intelligence that allows you to operate on a constantly, AI enabled models to be put on it, and you are constantly improving the operations of the network. What the whole idea is really is to create that single pane of glass at the end of the day. So a customer can look at it and say, from an operations team point of view, I've got my existing network with X number of functions sitting on this platform. I have new network platform that I've installed in one market or one instances, and I'm starting to move the workload from one place to the other, and I'm getting a seamless ability to manage my operations from an end-to-end perspective, and I do it through the portal. So I give sort of a hyperscaler experience in being able to manage the life cycle of the network. That's the purpose. That's the whole idea. And this is really key from our perspective to achieve the real vision of why we are doing all of this. At the end of the day, the purpose of all open technologies that we are inventing is to be able to give a autonomous, adaptive auto operations for the customers, right? For all the operators, so that for them, the ability to maintain, manage, and operate this network is completely seamless. It's auto looped, it's control looped, and automated. And honestly, this is the nirvana that we are trying to achieve. And our platform of AI NOF, as we have called it, is really driven towards that. So we have combined the NetOps.ai with AI-NOF basically to say NetOps.ai gives you the ability to orchestrate the life cycle, and AI-NOF is the part of that which allows you to operate that infrastructure in an automated and seamless way through the AI enablement. And that's really our vision in terms of how an end-to-end network can be transitioned, migrated as we go along. And at the end of the day, our job is to become an enabler for the network of the future and really enable this continuous life cycle for an operator in an automated way, fashion of planning, designing, integration, testing, deploying it, and then operating it and improving the customer experience by optimizing it and making it as a continuous cycle on a absolutely frequent basis. That's what we are all about. And with that, thank you so much. I appreciate the opportunity.
Oh, thank you, Manish. Awesome look at it from a bird's eye view. We definitely have a few questions for you. I think the one that would be relevant given your global perspective is, what you're seeing in terms of pulling things together, building on open source projects, bringing all these projects together, not just in networking, but networking plus AI plus edge, and effectively getting to that autonomy. Is this just driven by US carriers, European carriers, APAC? Where do you see, from a global perspective, where do you see this happening, or is it like all around the world?
Yeah, I think I would say it's actually very ubiquitous. I mean, if you had asked me or asked the same question around 12 to 18 months ago, I would have probably said that it was more Western and the tier 1 carriers globally who were mostly focused around that. But today, almost every conversation that I have with customers starts with automation and ends with automation. Mm-hmm. But the journeys are different based on where they are today, right? Some of them have a virtualized network that have already been tried and tested over the last 4 years, but the full value of the automation has not been achieved. So for them, it's more about how do I get this to the next stage and really go towards that fully automated network. For others, it's more of a how do I start the journey and where do I start the journey? But it's ubiquitous, it's across the world.
All right, very good. I think there's a couple of more questions. In a 3-tier architecture, as you see it, where is the enterprise as edge geographically, right? Is it on the prem? Is it leased, colo, shared facility, right? All of the above, where do you see that?
That probably is the multi-billion-dollar question at this point of time. I kind of see that as, clearly one place is the edge for the operators, the network edge managed and operated by the CSPs. That's a one clear place where it would reside as a place where it serves a larger community of enterprise customers. Then I see there are larger enterprises who are very clear in terms of their use cases that they say, I've got my factory of the future that I want to automate. I want to integrate my IT and the OT networks, and I want to put a lot of analytics at my premise so that I can actually control the maintenance and repair operation, or the asset performance management, or my supply chain that goes in and out of the manufacturing plant. There are manufacturing units who are clear that I want it on-prem. So some of them are moving to the on-prem, but I see it to be starting more at the network edge at the CSPs and then slowly moving into more into the enterprises.
Excellent. Well, thank you very much, Manish. That was very insightful for that global perspective. Thank you very much.
Thank you, Arpit. I appreciate it.
All right. So we have one of the top leaders in the ecosystem. If in fact, I would say a visionary that has really shaken up the entire open source market, right, in the last 5 years. And we all know Chris Rice, and we all know him from listening to him and following his leadership and direction. Well, he's now the CEO of Sterlite Technologies Limited Access Solutions, STL as we call it. And it's a different perspective because now he will probably look at this market differently. And we just thought it would be great to hear from him how he sees the world different. Obviously people know him from his amazing role at AT&T, but I don't think I need any more detailed introduction for Chris. So Chris, thank you for joining and welcome.
Hey, Arpit, thanks. I really do appreciate that. I'll try and live up to about half that hype that you gave me. But I chose to give a talk today on what I was calling delivering on the promise of OpenSDN, because, you know, those of you who follow like the Gardner hype curve, I think, you know, we've been through that roller coaster on some of this OpenSDN, but it's clear that we're in this delivery phase now. And, you know, what Manish was saying and Amar was saying around, you know, these end-to-end use cases and what they're hearing from customers, hearing that same thing. But I want to step back a little bit before I get into the talk deeply and just talk about kind of what I consider the phases of development that we've gone through, but maybe also another phase that we're getting into. And I think folks who spoke before me hinted around it. But, you know, as an example, you can look at the first phase, you know, maybe go back about 4 years, and there was SDN for wireline. It leveraged what happened in the data centers. You know, an example milestone is, you know, we're working on the Honolulu, the 8th release of ONAP, and clearly people have deployed it, and, you know, they've gotten value from it. And, you know, it was going up against, you know, systems that were decades old and delivering value. And so I think a lot of folks did a lot of hard work that they're proud of for that. And I think some of that learning, some of the learnings that came from that kind of was that next phase. And I think these were all still going concurrently, but there was clearly a next phase around, hey, listen, it's possible that my integration with the BSS systems that I have could limit my ability to put these SDN systems in place. And what do I go do about that? And I give credit, you know, that's maybe like a 3-year journey that we're on so far and still working, excuse me. But, you know, I give credit to the TM Forum, you know, their open API manifesto, Guy Lupo, his team in Telstra for network abstraction as a service. And so I think that was clearly a phase that was, again, meant to like knock down roadblocks. And then maybe something that we're on for about 2 years now is this kind of open SDN for wireless. And it was really started as a result of the fact that the other areas had momentum and that they could then go push and disaggregate the wireless network and have things like the, you know, RAN intelligent controller and XApps and all these other things that now are applying to the wireless area. And I think kind of coincidentally, and maybe not so coincidentally, around that same time, I think you saw the public cloud starting to get interested from an infrastructure standpoint in doing things around these open SDN solutions. But I think I'd argue that, you know, we're moving into another phase. And while all those other phases were strongly about innovation, and clearly there's innovation in this next phase, I think this phase is a little bit about synthesis. And, you know, Amar in his talk alluded to this, but, you know, if you think about it, what we really need to do now is look at what I would call open end-to-end SDN native solutions. And end-to-end and solutions are key terms there. You know, as we move forward, I'll talk a little bit more about that, you know, in my talk. But I think moving into this next phase is key because, you know, we're moving from ideas to implementation. We're moving from POCs to production. You know, we're moving from skunkworks to scale. And I think if we're going to continue on that journey and make those transitions, it's going to be important for this next transition to be able to help us move in that direction. So, you know, let me start by talking, and Arpit gave this, you know, I'm certainly talking for a new company and a new job since the last time we spoke. And kind of why is that? Well, one reason is that I saw this phase coming, right? I saw the fact that, you know, there was a need for this end-to-end solutioning for these open kind of native SDN solutions. And I really, quite frankly, wanted to be part of that. And it was something that I thought, you know, if I went and did this, that I could help telcos make this technology more consumable and more deployable based on some of the work that we had done in the past in my previous jobs. And so, you know, a little bit about the company, you know, STL Access Solutions, you know, it's a brand new business unit. It's a US-based company. It's dedicated to what I would call open SDN solutions at the edge. Think fiber and 5G, products, software, integration services. And, you know, kind of my favorite part about the job is growth. You know, 3 favorite things: real estate, location, location, location. 3 favorite things about the job are growth, growth, growth. You know, we're growing teams in all the areas. We have an existing core team in India. We're growing that team. We're creating a new team in the US. But certainly we recognize that talent's worldwide, and we'll be smart about, you know, how we go and attract that talent. You know, it's part of a much bigger company in India. STL parent company is kind of known as a digital integrator, optical connectivity company, does fiber deployment, network integration services. So it's a new business unit associated with that. And really, quite frankly, the goal of STL Access Solutions is to take advantage of these trends and momentum in the ecosystem that you've been talking about, we've been talking about at the conference, and others before me have been talking about. And quite frankly, to scale the business for commercial success of these open end-to-end cloud native solutions. And basically to do that, work in open source fora and what I'll call open source standard and standards aligned to that, is critical. And as you all can see, I'll say it takes a village to be part of this ecosystem. There's not a lack of places that you can participate, and I certainly won't read these. I think everybody on the event today is familiar with them. But I think what I would say is that as we look at customer requirements, specific requirements, and specific call-outs in RFIs, RFQs, RFPs, the participation and contributions in these areas in providing solutions that align with the work that's done in them, is required. That's a significant part of the conversation that we have when we talk to customers. And so I, just kind of like to recognize the folks that do this, that hard work is paying off, and we're starting to see some momentum changes. But I think, and I'm going to extend even what Amar said a little bit further, which is, I think cooperation, greater cooperation between the bodies that I show here and even others is key to gaining traction. It's key to gaining momentum. And I'm going to go in a little bit more about that. But, kind of my takeaway from this is that what telcos are buying is changing. They are buying more open, more cloud native, more SDN-based solutions. But quite frankly, how they're buying isn't really changing. They're still looking for someone who's going to do end-to-end. They're still looking for someone to take responsibilities for the areas of domain that you're providing a solution in. And so a little bit maybe of what I'd call that dichotomy has to be recognized as you move into this next phase. And so let me use that to transition to what will be, my company's priorities for 2021. And since I'm like 9 days, 10 days into the job, I reserve the right to modify these a little bit with time. But our goal is basically to take advantage of these opportunities, open networking opportunities at the edge. And think fiber and 5G. 5G obviously worldwide, fiber worldwide, but fiber especially in Europe. We're seeing a lot of efforts there. And so how are we going to do that? Well, look, one of the ways we're going to do that is obviously organic growth of our own products and services and software. But part of it is also to find the right partnerships to supply this, what I'll call full service end-to-end delivery of these SDN data solutions. It's a recognition that it's likely going to take more than one company to go and do that. And then I think if you look at the members of the ecosystem, there are things that STL Access Solutions can do to kind of complement and fill gaps of others in the ecosystem. And think of those as like other, what I'll call disruptors, cloud players, system integrators, and maybe even some OEMs. And so our whole goal, again, is to make it more consumable, more deployable, and to bring this end-to-end mindset, which is key. Because again, the way they're buying isn't changing. And so in my mind, to be successful here and to talk about everyone's priorities, if you will, who want to be a part of this, is embrace this open end-to-end SDN native movement. Embrace the fact that you're going to bring a full service solution to the table, because how telcos are buying is not changing and it's not likely to change. And at least for us and the way we're building this company, we're going into this and say we're building a business plan and a cost structure for the company from the ground up to basically embrace this movement and to gain traction in this SDN native solution space. And so, one of the things that I think would be useful is to understand, well, how can the ecosystem itself help? What can we do in the ecosystem? And I'm going to echo a little bit of what Amar said, but I think I'm going to extend it a little bit. And so, for instance, you can think about use cases that encompass infrastructure, network system, BSS flows, operations. And so these kind of use cases move from what I'll call isolated use cases to integrated use cases. And clearly that super use case at Amar is an example of that. But I would argue that you still need to add some things around operations and BSS flows to that because that's what's important to the telcos. That's how you're actually going to make these sales. That's how you're going to close their sales. That's how they're going to move from the products and services that they're on to these open SDN native solutions. And again, I think this is key to gaining success in these solutions. And again, movement from, ideas to implementation, movement from POCs to production, and movement from skunkworks to scale. Those are the kind of things that you should look for in the market and in the industry to basically what I would call milestones of success. Are we actually doing that right? At least the way I'm thinking about this is, think about an ability to have what I would call a network ready icon, but that network ready is end-to-end solution based, and it deals with infrastructure on obviously various platforms that we've talked about. It deals with the service areas, it deals with the application areas, third-party applications, OSS, BSS, and operations. Those are the kind of things in a specific domain. You can't be all things to all people, but if you're going to be in a domain, those are the things you got to cover to really say that you're going to be doing something end to end. And so with that, let me just close there, say I'm super excited to be here talking with everybody today. Very excited to be the new CEO of STL Access Solutions. And let me see if in the next few minutes, there may be a couple questions about what I've said.
Absolutely. And for those of you, who have questions, there's a Q&A button on the right. Please fire them. I'm sure it's coming over. But Chris, I think the thing that always amazes me is every time you speak and do keynotes for the industry, I always learn, a few words or phrases that simplify what we all have to do, right? Like, I love how you sort of said it in 3 lines, from POC to production, skunkworks to scale, and from isolated to integrated use cases. So I think that was kind of the theme of the whole conference, and I think you hit a home run by just saying that. I think I think we're starting to get questions here, but how do you see convergence on the at the access layer, if you may, right? Because you have specific broadband access, 5G may, 4G had some fixed wireless, but, it may replace, or 5G may replace or add on to it. And how do you see the convergence happening in that layer now that RAN is starting to get disaggregated with O-RAN and all that? So in general, from an access evolution perspective, because a lot of emphasis has been on core, right? Then we moved into the edge last couple of years, which, still going on, and now into access. So how do you see that?
Let me slice that a couple ways. I think one is, for instance, let's talk about edge. Well, the reality is, for edge use cases, by definition, if you're going to have low latency, then you as the operator need to own that link. You need to own that access link. And let me just give you an example, and that's true for wireline or wireless. And let me give you an example. If I happen to have a POP, point of presence, right by an enterprise, and let's say that enterprise doesn't use my broadband, but they use some other third-party broadband, even though I'm literally right across the street, it's possible that, the head end of their equipment isn't even in the same city. It might be in Denver if they're in Dallas. And then the flow and the latency associated with the flow has to do with, well, when does my network touch theirs and where does it touch and everything else? And even though it's right across the street, it could have a high latency flow. So being on the edge and actually delivering on the edge and low latency at the edge, there's a definition of access. There's a definition of ownership of the access link to be able to do it so you can deliver on that promise of end-to-end latency. And I think from my standpoint, fiber and 5G, if you will, they're like peanut butter and jelly. In other words, I can't go and think about improving my 5G unless I've gone and improved my routing capability at the cell site, my backhaul capability at the cell site. I can't deliver on a end-to-end slice if I don't have the ability to do it just more over the air link or just over the mobile core, but I got to be able to do it over my access network, the metro network, and in the core itself. And then running use cases that look like that are key. And so in my mind, these things, this edge and access and wireline and 5G and the apps that go with them are integrally linked. And that's why I was kind of pushing for this. This is why we need these end-to-end use cases, because you can spend a lot of time doing things that look really good in the lab, but you want to make sure that it actually follows through on these customers' networks and works in production.
Gotcha. Very nice. There's probably one more question. Several have come up, but I'll just try to sort of summarize that.
Yeah, I don't know if you want to just send me these in email. I don't know what the process is.
Yeah, we could do that, and Jillian will work with you directly to get it to you. But I think the question is really around how do you see the companies, the service providers, right? Have they really moved into an execution and an implementation phase, or are they still playing with open software and things like that?
Well, I think it's hard to talk about everybody, right? But let me just say this: that when we started down this path, it was clear that there were only a few kind of pioneers, and then more people got on board. But going back to what Manish was saying, that I don't have conversations with customers that don't have this as a core component. I mean, I didn't write down the slide because I was speaking at ONEF. I mean, people are asking like, well, what are you doing in this space? What is your contribution? How does this align? Where are the points of interface, right? And so, and they're coming out with RFIs, RFPs, RFQs that are aligned to that. In other words, I want a solution that's aligned to this. And I think then the impetus becomes showing them that you can do that in the way that they want, but do it at scale and take end-to-end responsibility. In my mind, that's the key. And I don't know that there are a lot of folks who can kind of go and do that on their own, maybe other than the incumbents. And I think that there's an interest to provide a growth in the ecosystem. So it might be that, folks have to figure out how each of us to complement one another, as opposed to kind of trying to do everything on our own.
Yep. The true power of collaboration. Excellent. I mean, this is what you had dreamt of. So I think, and given leadership to the entire ecosystem. So really, Chris, we really appreciate, and congratulations on your new role. We'll be seeing a lot more of you given that you are now sort of moving into the access phase. But again, thank you very much for joining. Thank you.
I appreciate it. Thank you, Arpit.
All right. And for the participants, we will take a short break here. Go get some coffee, get some cookies. Again, wish Linux Foundation could provide those. You'll just have to go to your own refrigerators and get food and things like that. But we will be back exactly at 9:05 Pacific, 12:05 Eastern, and various time zones. So join us in the afternoon. Some fantastic keynotes in the afternoon, right? We have the top leaders, right? The Ericsson, the Nokias talking. We have a very interesting presentation from Facebook. I'm just reading this so that I don't miss anything. And LinkedIn, sort of the top web companies going for open source and global connectivity. And we'll wrap with Arash, who is kind of the SVP CTO from Deutsche Telekom and a big contributor to open source. So stay with us in the afternoon. Join us back at 9:05 Pacific, 12:05 Eastern. Thank you very much.